So with this group that we didn't add, this group that was applying to an astronomically large number of colleges, what did this do to our mean? Made it bigger. Did it increase it substantially or not that much? Substantially. What was our old mean? 12.86. So that went up quite a bit. Like what? Right around 3.5 colleges? What about the old standard deviation? 4.05. That went up a lot, didn't it? Do you guys remember how we described what standard deviation is telling us about a group?
Says something about differences or something.
Yeah, it's the typical distance from the mean. Typical distance from the mean. So how far away on average on either side we would expect normal to be. Does that make sense? When I talk about things being normal or not normal. Like, those values wouldn't surprise me. If we had a group that said, oh, between the four of us here, we're going to apply to 100 colleges, would that surprise you? Yes. That is very, very large. That's an unexpected value. If there was a group that said, out of all four of us, we're only going to apply to one college, would that also be surprising?
Yes.
Yes. So standard deviation gives us an idea of, like, we might know what the mean is or what the median is, but we know that not everybody falls right on the mean or right on the median. And so this gives us a way to talk about what we would expect plus or minus that amount. It's like, that's all expected. That's all pretty normal. That doesn't surprise me. What was the old median? Did our median increase? Not really. I mean, a little bit, but in comparison to the other two, the median went up by 0.5. All the others changed quite a bit. So I'm going to write that down. The mean and standard deviation. For right now, I'm writing STDEV, but eventually I'm just going to abbreviate it SD because we talk about standard deviation so much in here that SD will be standard deviation. The mean and standard deviation changed a lot. The median was mostly unaffected. Median is mostly unaffected. So we say that the median is resistant to outliers. If something is resistant, what does that mean? Yeah, it's not affected by it, or it's not affected much. It's not very movable. If something is resistant to change, it does not want to change. That's the way our median is. The mean and the standard deviation are non-resistant. To outliers. These are much more strongly affected. Why do you think that is? Why is the mean affected a lot by an outlier and the median is like, meh? Yes, ma'am.
Because when finding the mean, you take all the numbers and use all of them. Well,
Yes. Yes. Could you guys hear the explanation?
Yeah.
So basically, when we're talking about doing the median, we're going to put things in order from smallest to biggest, and an outlier is going to be the first thing crossed off. It's going to shift the middle a little bit, but no more than something that's not an outlier that gets tacked on the end, because it's just one more number to our data set. Whereas the average, I always think about grades when I think about average, because that's what your grade is. If you bomb a test, you get a 0, and you're normally an A student, what happens to your grade? Yeah, like, there's tears, right? If you get a really low score on a test, you see that impact immediately. And that's probably not a great description of you as an overall student, because you do really well on all of these others, and you've got one bad apple in there. All right, go ahead and flip this page over. I need you guys to copy this down into the important ideas box, and then I want you to try to check your understanding on your own. I'm going to give you guys 5 minutes, and then we'll talk about the check your understanding together. All right. If you've not had a chance to answer every question down below, that's okay. If you've just started looking at it, that's okay. But I do want to go down and kind of debrief that. So how do we calculate the mean for these cities? Add them and divide. How many cities do we have? 9 cities. So I'm going to add them all up, and I'm going to divide. I got 34.94. Because context is so important in statistics, including units on things, while in other math classes, if you left off your units, that might be okay and permissible, you have to include units because that's where your context is in statistics. So make sure that you're putting inches. You could write out inches of rainfall, but inches would be sufficient to give us context here. And then the median, my middle value, is 40.5. So I'm just curious, while we're looking at this histogram here, where would the median be on my histogram? Median.
From 35 to 40.
Yeah, so like 40.5 is going to be like here-ish, right? If I were just using the number line at the bottom to help me figure out where 40.5 is. Where is the mean on there? Yeah, like right barely before the 35, right? Practically right on it. So here's my mean. Why are the mean and the median not the same? Why is the mean smaller than the median? Yes, is that what you were going to say? Absolutely correct. So it is skewed to the left because we always go in the direction that the tail is. Like whichever way the mean is getting pulled, if it's getting pulled down, it's being pulled to the left. So we have a left skew. Awesome. Anytime you're looking at a histogram, even if we don't know what the mean and the median are, you should be able to tell me, well, the median would be about-ish here. You might not have a precise value, but it's right around where that big bump of data is. And the mean is going to be smaller than that because of those outliers. All right. I would use the median here to describe my distribution because the rainfall is skewed left. Remember, when our data is roughly symmetric or symmetric, we're going to use the mean. When it's skewed left, skewed right, we're going to have the median as the best measure of center. And the way I would interpret the standard deviation there, they gave us what the standard deviation was, and they just asked me to interpret that in context. The annual rainfall for a city typically varies by 15.52 inches from the mean of 34.94 inches. There are several things that this sentence has that you need to make sure that you are getting these big ideas. You don't need to use my words, but you need to be hitting on these ideas. The first one is context. So here we have context. Typically varies. This is what standard deviation does. And it's telling me how much it varies by, and then from the mean, because telling me that it varies, telling me that it could go this way or that way, if I don't have a reference number, it doesn't tell me a lot. So looking at this, reasonable expectations for rainfall, things that wouldn't surprise me, from about 20 to 50 inches. 20 to 50 inches of rainfall seems pretty normal. If it's going to be a lot more than that or a lot less than that, those would be things that would surprise me. Does that make sense? That's what our standard deviation is describing. I'm going to subtract that from my mean to get the lower bound, and I'm going to add that to my mean to get my upper bound, and anything that falls in that window, I was like, yeah, I'm good with that. Things that are much smaller than that or much larger than that that would be surprising will be points of interest for us. You guys okay so far with this? Okay. I want to get you guys up and out of your seats for just a minute. I want you to put yourselves in order by height right up here at the front of the room, because this is where I got like the most space. So put yourselves in order by height. Let's do shortest on that end and tallest over here. I'm going to sneak through right here. Sorry. All right. We're probably going to have to get closer to the board. We might need to wrap around the edges. That's okay. We've got 21 people in the room today. So that might be more people than we can do. We might need to like scoot around. Feel free to kind of scoot further towards the board that way so we've got some more room to fit people in.
Go
I
down
want to
there,
get in
please.
order by height. Got just a couple more people to fit in. Let's scoot down just a little bit. Squeeze in. Let's come around just a little bit more. Okay, perfect. So if we have 21 people in the room today, where am I going to find the median?
Right there.
Person number what? If I cross off from each side. It'll be 10 on either side, right? So we need to find person 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You are person 11. Okay. So I want you to stay there, and these two groups, I want you guys to move to the edge of the room. Sorry, median. Median's not going with either group. Why?
Both sides.
Yeah, like she's the dividing line. What would we do if we had two middles? Yeah, we're going to average that, but that means that like if I have two people in the middle, one's going to go with one group, one's going to go with the other group, and the dividing line falls between them. All right, so I've taken my group and separated it into how many pieces? 2 pieces. Approximately how much of the class is on this side of the room? Percent?
Oh.
About 50%, right? This side of the room? 50%. I'm going to break you guys into quartiles now. Quarter. How many quarters in a dollar? 25 cents. 4 quarters in a dollar. So I'm taking my big group and I'm putting it into 4 pieces. All right? So over here, we've got 10 people, right? if I wanted to know what the actual, this would be called the first quartile, this dividing line here. Since I don't have a person on that line, and we've got 5 in each group, if I wanted to know what that value was, I would take your 2 heights, add them, and divide. So that I know where my dividing line is. Does that make sense? All right, over here, I'm going to split you guys in half. 1, 2, 3, 4, 5, right in between you 2 gentlemen. Here we go. What percentage of the class, approximately, is in each group? 25% of the class is in each group. So far, so good? This is what we're going to be doing with our data. So let's go ahead and take our seats. We're going to look at another class's distribution of heights. But we're going to be doing with these people's heights exactly what we just did here. So the first thing that I want you to do, we've got the class data right here. I want you to make a dot plot out of that. Go ahead and make a dot plot for me. This is on the next page. This is Ashmita's 4th period AP Stats class. Why are the numbers so large? How are they reporting their data?
Inches?
In inches. So we don't have anything like 5'8", we have 68 inches. Because we want to use just 1 unit of measurement here. Hopefully you're getting a dot plot that looks kind of like mine. And there's a couple nice things about having constructed our dot plot when it comes to answering the next 2 questions. What are we supposed to do on number 2? Find the median. Does that mean I need to take my whole big long list from the beginning and put it in order? I mean, yes and no, but my dot plot kind of put it in order for me, didn't it? So I've got my dot plot giving me these values in order. Let's find the middle. Let's find the median. $63. How'd you find it?
I just kept crossing off.
Absolutely. Crossing off till you get to the middle. Take my pen. 77 would cross off with 57. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. 1, 2, 1, 2. 1, 1. I've got this guy left right here. So far, so good? All right. So now that I know that that one is the dividing line, and it was the one that was up on top, right, as I crossed out from the middle, I want to find Q1 and Q3. How do I find Q1 and Q3 from this? Split them up. Yep. So I'm going to take everything that is below and to the left of my median. That's my lower half. I'm going to cut that in half. So I'm going to cross out and find the middle again. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This guy goes with that group, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, this guy actually belongs to the other group. part of my larger group there. One, two, three, 1, 2, 3. Okay. So I've got these two people in the middle. What is my Q1 then? 61.5. I have to average those two. Then I'm going to do the same thing for Q3. We're going to cross out from the ends. 1, 2, 3, 4. 1, 2, 3, 4. These are my two in the middle now, 65 and 68. How do I find Q3? Add them together, divide by 2. So 65 plus 68, divide by 2. So that's what, 133 divided by 2. I'm doing mental math, and that's dangerous. Please tell me if I did anything wrong. That would give me 66.5. Okay. You guys following along with how we're getting these? Okay. So my mean is 63 inches. We crossed off until we got to the middle. Q1 and Q3, 61.5, 66.5. All right. From this, I now have all the information that I need to construct a 5-number summary, which is what I'm going to use to make my box plot. What was the minimum height from this class? 57. What was the maximum height? 77. We said that Q1 was 61.5. My median was what? 63. And Q3, 66.5. Q1 and Q3, these are standing for quartiles. First quartile and third quartile. A lot of times students will ask me, what happened to the second quartile? Well, when we took our group and it was broken into 4 pieces, think about the way we were around the room. First quartile split my smaller group in half, right? And then what was right here? Median was cutting my group in half. That's our second quartile. And then we moved around to our third quartile. We don't call it Q2 because we have a better name for it that we're more used to. All right, I'm going to make a box plot. Have you guys built box plots before?
Yeah.
All right, so I need my minimum on here over at 57, which didn't make it on my graph. So I'm going to put a little dot. Sometimes you'll see people that do a slash here. You just want to mark that, like, I didn't forget to finish this line. This is like the end point, right? So here's my minimum. 61.5 starts my box. And that's going to go all the way over until 66.5. 63 is my median right here. And then 77, way out here. What do you notice about that distribution?
Skewed.
Yes, it is skewed to the right. We got a long tail out to the right. Do you think it's possible that we have any outliers? Yeah. I want to calculate something called the interquartile range first. The interquartile range is Q3 minus Q1. So I want you to find that real quick. Q3 minus Q1.
5.
Oops, sorry. I did not mean to go to the next screen. My apologies, guys. Oh, no. I'll go back to the other screen. My thing's messing up. Why is it doing this? I'm getting really annoyed with it right now. Okay. There we go. That box in my box plot is the IQR. That width there. So I'm going to go back to where I can see the box plot. I'll come back to this screen, but I want to mark on this picture that from right here to right here is the IQR. All right, back to this. Outliers. We're not going to have to guess about what makes an outlier anymore. We have a way to test to determine if something is an outlier. The way we test for an outlier, we're going to do 1.5 times whatever our IQR is. So in this case, it's 1.5 times 5, because we said our IQR was 5. I'm going to take that 25% mark, my Q1, and I'm going to minus 1.5 times my interquartile range. If I have any values that are smaller than that, we would consider those way too small. Those are small outliers. That's unexpectedly small. For my large outliers, instead of subtracting, I'm going to add on. My third quartile plus 1.5 times my IQR. Any values that are bigger than that, I would consider to be unexpectedly large. Okay? So I want you guys to do this. Take our Q1 and minus 1.5 times 5. See what you get. Do the same thing with Q3, only this time you're going to do Q3 plus 1.5 times 5. What is our threshold for way too small? 54. What's our threshold for way too big? 74. 54 and 74. Do we have anybody in Ashmita's class who's smaller than 54 inches? No. So there are no low or no small outliers in this particular class. Do we have anybody in this class who has a height that is more than 74 inches? Yes. So we do have a large outlier. That's 77. What this means is that on my box plot, to represent it accurately, I don't necessarily want my outlier to be shown as this big, long, outstretched arm. I'm going to mark it separately. Have you guys ever heard of a modified box plot? No? Okay, that's fine. Some people have heard of it. That's why I bring it up. A modified box plot says, I'm going to take this outlier And I'm going to use a symbol here like a star to represent my outlier. But the stem or the whisker off to the side of this box, it's going to go up to the next number that's not an outlier. What was the last height value that we had that is 74 or smaller? 72? All right, so I'm going to have a dot at 72. Even though I know that that's not my maximum, we decided that 77 was uncharacteristically large, and so I'm marking that separately. Overall, what did that do to the appearance of our box plot? Makes it look much more balanced. Now I see that almost all of the data in this group is pretty balanced, roughly symmetric, except for this one unexpected value. Does that make sense? Okay. This is called the 1.5 IQR rule. When you're looking at your data and you're trying to determine whether or not there are outliers, this is how you will determine for sure whether or not there are any outliers there. Ashmita herself is 5'3", 63 inches tall. She is that median value. So half of her classmates in fourth period are shorter than her, and half of her classmates are taller than her. On the back side of this page, there's another like important ideas box. Big important takeaways. That is the last thing we're going to look at for today. I want you to make sure that you get this into your notes. The 1.3 homework is due tomorrow. And today is the last of the new material that we're covering in Chapter 1. To make sure that we're well prepared for your first test, we're going to spend several days reviewing. Your test is a week from today. So we've got tomorrow and Friday, Monday and Tuesday to review. We're going to spend 2 of those days practicing doing free response style questions that are similar to what you would see on the AP exam. They're from old AP exams. We'll do that Friday and Monday. Tomorrow, I want to take some time to just kind of practice with these skills and ideas. And so we'll do an activity in groups to review. I'll also give you a printed out test review for you guys to take home and practice with.